Hello, good morning everybody. My topic is super resolution using GAN. Now let us know what are GAN. GAN is a generative adversarial networks. GAN are a deep learning based generative model that is used for unsupervised learning. Now let me show you with an example. Here are two pictures of neural networks. GAN consists of a pair of neural networks that fight each other. One is called generator and the other is called discriminator, as shown in the figure. And it looks like a counterfeiter and a cope. The counterfeiter is trying to make fake paintings and the cope is trying to catch the counterfeiter. Here I am just taking an example of paintings. We can say with any example like money, fake money or original money. If a counterfeiter fakes a cope with a fake money, that's also an example, but now I am taking an example of a painting. That means a counterfeiter makes many paintings which show similar as the original one, and the copes try to catch this fake paintings. Here the counterfeiter is generator and the cope is a discriminator. The counterfeiter keeps improving and improving his paintings until he learns the final paints look like the perfect one, means like the original one. He tries improving his paintings. He's trying to fool the cope. He improves his painting as it looks like the original one. This is here we can see this generator is a counterfeiter and a discriminator is a cope. Now in neural network what happens means we have a pair of neural network, the generator and the discriminator. We train them with a set of real images and set of fake images generated by generator, and the discriminator identifies which image is real and which is fake. This is the process happening here. Now why GAN? Why we use this GAN? Generative adversarial network is the most interesting idea in the last 10 years in machine learning. It's just introduced few years later, but nowadays in the research areas it's a very popular one, that GAN in deep learning, in machine learning we are using it, and the researchers are continuing in this topic. And my topic is super resolution. Basically the definition of a super resolution means converting low resolution images to high resolution images. It is basically task of converting a low resolution images to high resolution image. The way in which low resolution image differ from high resolution image is that the number of pixels packed into an area is lesser in a low resolution image as compared to high resolution image. Now let us see some previous work on super resolution. Here there are 4 steps. First one is interpolation techniques for unsampling bilinear nearest neighbor by cubic. Initially in 1980s, 1990s, people used the interpolation techniques for unsampling like bilinear, nearest neighbor, by cubic, etc. This where people were used in past days. Next, SR using CNNs, that is good alternative to traditional filtering techniques. Later in 2010s, when deep learning took over, deep learning came to the field, CNNs turned out to be very good alternative compared to the interpolation technique used in past. Then SRRES nets deeper CNNs for the better performance. Then people want to use deeper networks, so this SRRS nets came to the picture. Now last came the SR-GAN. SR-GAN is Super Resolution Generative Adversarial Network. This is also known as SR-GAN. Last come to this topic, SR-GAN stand out from the three techniques used in the past because they are able to produce more realistic images compared to ones in past, because it is more better and more realistic method which were and which is better than the methods which we used in past. So now we are using the super resolution GAN. So now let's go into the architecture of SR-GAN. Similar to GAN architectures, the super resolution GAN also contains two parts, generator and discriminator, where generator produces some data based on the probability distribution and discriminator tries to guess whether data coming from input dataset or generator. Generator then tries to optimize the generated data so that it can fool the discriminator. So here the image given shows the architecture of SR-GAN. Initially, low resolution image is given as the input and later it is passed to the convolution parameter. You can see here, and here there is one block called B residual block. You can see in this image, and there are 16 blocks contained in this residual blocks. Each one of them contain a convolutional layer, batch normalization, here you can see BN, that is batch normalization, and parametric ReLU function. The end of network there are pixels and produce super, and last it produce output as a super resolution image. The upper image shows that. Now while coming to the discriminator network, now we told about the generator network. While coming to the discriminator network, in case of discriminator network, this given along with the high resolution image to the discriminator network, which again passes through convolutional layer and leaky ReLU function, and last we come to see that it passes through sigmoid activation function at the end of network, which it identifies whether the given image is fake or real. So this all what is say about an architecture of SR-GAN. Thank you. That's all for today's lecture.